collision? Collision is the strong physical interaction among objects. It is a strong physical interaction. A strong physical interaction. Physical interaction. A strong physical interaction. INTERACTION. A strong physical interaction among objects. Among objects, which involves exchange of momentums, which involves exchange of momentums, is called as collision. What is a collision? Collision is a strong physical interaction. That strong physical interaction involves exchange of momentums. That means when two bodies have the physical interaction, right? Physical interaction, and at that moment exchange of momentums takes place. That means one body momentum transfer to another body momentum to transfer to this body. Like that, the exchange of momentums takes place. In collision, right? Sometimes it is no need to hit together, right? It is not compulsory to hit together, but the exchange of momentum should be takes place. That's all. Okay, without hitting together, how exchange of momentums takes place? You studied, I think, Rutherford alpha scattering. Have you studied in any time Rutherford alpha scattering? Do you know? when alpha
Yes, sir.
when alpha particle is thrown towards the gold nucleus, when alpha particle is thrown towards the gold nucleus, and due to the repulsion, for example, this is alpha particle. This alpha particle has the plus 2e charge, and this is a positively charged alpha particle. And this particle, if it is thrown towards the gold nucleus, okay, this is a gold nucleus, and what happened? And when it is going this side, and this is a charged body, and this is a charged body, and both are like charged, that's well what happens at here, and the both are repel with each other. Due to that, the speed of alpha particle will be reduces, and the direction of motion of alpha particle also changes. If alpha particle is thrown like this, and it can go like this, what happening at here, its direction of motion is changing, and its momentum also changing. It maybe comes to rest, or it may be go back like this. And then how the velocity and direction of motion changed it here without touching with it. When you throw this, it cannot touch with this, but without touching also there is a force between them, right? Due to that force, its velocity changed, momentum changed, and direction of motion also changed. And this is also one type of collision. That means it is also involves exchange of momentums. Okay, in collision, for example, bus and some lorry are collide with each other, then they have the physical interaction. Direct, they are hit together, and during that their velocities will be changes. There is a direct collision, but sometimes without hitting together also, due to electrostatic force or any other forces, and the there is a change in velocities and momentums. Collision is a strong physical interaction which involves exchange of momentums. That means one body momentum transfer to another body momentum to transfer to this body, and this is the collision. And the collisions are two types. Okay, these are these are two types. Okay, collisions are two types basically, right? The first one is the elastic collision, and the second one is the inelastic collision. Okay, elastic collision, and the next second one is the inelastic collision. What is elastic collision and what is inelastic collision, and what happens in that we are going to discuss. And first I am going to start the first one, that is elastic collision. What is elastic collision? In that, what happens? Elastic collision means it is a strong physical interaction. Okay, in this, before and after collision, the body obeys the law of conservation of momentum and kinetic energy. Both are obeyed. Okay, and that means in this collision, if any collision, in a collision, if kinetic energy and momentum both are conserved, then such collision is called as elastic collision. Right? In this, what happens? The collision in which momentum and kinetic energy both are conserved, means constant. If both are conserved, then such collision is called as, right, elastic collision. Elastic collision is the collision in that total momentum is constant and the total kinetic energy is also constant. Momentum conserved, kinetic energy conserved. Okay, right, is called as elastic collision. In elastic collision, what happens? Both the momentum and the kinetic energy are conserved. Look at here. What we are telling it here, the total momentum is constant. Total momentum is constant. Momentum conserved means total momentum is constant, and kinetic energy conserved means total kinetic energy is conserved. In a collision, if total kinetic energy and total momentum both are constant, then such collision is called as elastic collision. And example for the elastic collision, in real life you will see that we cannot observe this type of elastic collision in the real life. Why? Because in real life, the total kinetic energy does not constant. For example, if car and lorry, if both are coming with high speed, initially they have lot of kinetic energy, but after colliding with each other, they not have the same kinetic energy. Right, after collision, after hitting together, they not have the same kinetic energy. The kinetic energy converted in the form of heat or any other forms. That means there is a loss of kinetic energy in the real life collisions. Then what we are seeing, the type of collisions are the inelastic collisions, not elastic collision. That is a what is elastic collision? For example, collision between the fundamental particles is said to be elastic collision. Okay, collision between fundamental particles. Okay, collision between the two protons, collision between the two electrons. Okay, what are the fundamental particles? Do you know? Right, protons, electrons, neutrons. These are the fundamental particles. And if the collision is occurs between these particles, then such collision is said to be elastic collision, right? And in elastic collision, with how much momentum, with how much kinetic energy the protons are coming before collision, after collision also they will go with the same kinetic energy. Then that is this is elastic collision. Now let us go for the inelastic collision. I am going to rub this. Right, if you want text, you can take the screenshot. Okay. Now, what I am going to start? Tell me. Huh? Second type of collision. Second type of collision. What is that? Can you tell? Yes, it is the inelastic collision, right? Inelastic collision. Then what is inelastic collision? Okay, Collison collision. Inelastic collision means the collision, the collision in which only momentum conserved, only momentum conserved, but not kinetic energy, but
Sir,
kinetic energy not conserved. Just tell me.
sir, how momentum is conserved?
Hmm? Momentum means
सर
ah,
सर उसका एक एग्जांपल दीजिए ना सर.
momentum means we can continue in continuation with example. I will explain how momentum is conserved and how kinetic energy is conserved. Okay. In the
Yes,
continuation, we
sir.
will discuss that one. The collision in which only momentum conserved but kinetic energy not conserved. That is said to be inelastic collision. You see here, uh, momentum conserved means the total momentum is constant. Total momentum is remains constant means before collision how much momentum is there, after collision also the same momentum is there. That means in the both the collision, either inelastic or elastic, in the both the collisions the total momentum is constant, but the total kinetic energy is not constant. That means energy loss occurs in inelastic collision, but in elastic collision there is no loss of energy, there is no loss of momentum also. Here the total kinetic energy is not constant. Total kinetic energy is not constant. Kinetic energy does not remains constant. Okay, that this is inelastic collision. Now let us see uh, one more. I am going to explain what is one dimensional collision. Here what happened in inelastic collision, what happens? Loss of kinetic energy occurs, na? Yes, loss of energy occurs. Loss of kinetic energy converts in the form of heat energy. Okay, and now what is one dimensional elastic? One dimensional elastic collision means what? Okay, one dimensional elastic collision. I'm going to explain one dimensional elastic collision. One dimensional elastic collision. One dimensional elastic collision. Okay, we have to give example for this. Na? I forgot to give the example for this. Yes, what is the example? That whatever that collisions we are observing in the real life, that are the inelastic collisions only. Right? Collision between two vehicles, right? Or collision between the two marbles, that are the inelastic collision. Now I am going to start the one dimensional elastic collision. What is one dimensional elastic collision? In elastic collision, before and after collision, if the objects travel along the same straight line, along the one axis, one dimensional means only one line, right? Collision before and collision after, if the objects travel along the same straight line, then such collision is said to be one dimensional collision. That means uh, in a collision, before and after collision, if objects travel along the if objects travel along the same straight line, along the same straight line, that means straight line means one axis. Before and after collision, if the objects travel along the same direction, same straight line, okay, then such collision is called as one dimensional collision. There is a one dimensional collision. But elastic means again it should follow two conditions: momentum should be constant, kinetic energy should be constant. Okay, it is a one dimensional collision definition I gave. But one dimensional elastic collision means in one dimensional elastic collision, right? In one dimensional collision, if momentum kinetic energy both are constant, then that is said to be one dimensional elastic collision. This is one dimensional collision. That means, for example, this is the first object, mass m1. This is the second object, mass m2, right? And they are moving with velocities u1 and u2 initially. And for example, the first object has more velocity, and then this is the before collision. After some time, they are collide with each other like this, right? After the collision, they are going like this in the same direction they are going, but they have the different velocities, right? And their velocities are changed, but the direction of the motion is not changed. The all the objects are traveling along the same straight line, right? And this is the straight line along which the all objects are moving, right? And this type of collision is said to be one dimensional collision. Okay, and the next I am going to explain one more important topic, right? And we are going to derive the find velocities of two objects in one dimensional collision. I am going to rub it. Right, the most important topic I am going to discuss, very important. There are two questions are there based on this. That is the show that relative velocity of relative velocity of approach is equal to the relative velocity of relative velocity of separation after one dimensional collision. After one dimensional after one dimensional after one dimensional elastic collision. This is one. And the second question, there is one more question is there. This is for 3 marks question. Very important. There is one more question is there, that is for 5 marks. They may ask like this. Very important question. Derive expressions for final velocities of two bodies. Final velocities of two bodies or two objects after one dimensional elastic collision. One dimensional elastic collision. These are the two questions. Okay, and this is important for the 5 marks. Very important. Okay, right, let us start. Anyone uh, for both explanation is same, but it is little lengthy and we can continue, and it will be close in the middle, and it was very easy, just like one mathematics problem. I am going to derive it, and it takes more 15 minutes. I will continue up to 12:45. Okay, will you accept or any problem? Students, are you there or not? Yes. What are you
Yes,
doing?
sir.
Okay. I'm going to continue for the more 15 minutes, and listen carefully. And I'm going to rub these questions, and then I will answer for these questions. Okay?
Yes, sir.
Okay, very good. Now I'm going to answer for this. First, I'm going to write the heading, that is the one dimensional elastic collision continuation. What they are asking the question, one dimensional elastic collision only the question, right? Already one dimensional elastic collision means we know what is one dimensional elastic collision and what we are going to prove in this, and you listen very carefully. Yes, let us start. Consider the two objects. Okay, let us take the two objects and the this is a straight line. Let us take the two objects. This is the first object whose mass is m1. It is moving with velocity u1, and this is the second object whose mass is m2. It is moving with velocity u2. This is the situation before collision, right? Before collision, and here we are considering that before collision u1 greater than u2. Now the objects are collide with each other here. This is the during collision. During collision, the first object applies the force on the second object, and second object applies the force on the first object. This is the during collision, at the time of collision. And after the collision, I will write after the collision. This is the first object whose mass is m1, and this is the second object whose mass is m2. And after the collision, they are going with the velocities v1 and v2. Before collision, their velocities are u1 and u2, and after the collision, their velocities are v1 and v2. Now, this is we are telling that what is our question. The first question is that question 1 is that the show that the relative velocity of approach before collision they will approach. Is it right? They will come closer to each other. First body has more velocity, it will go fast and it will comes closer to the second object and it may be collide with the second object. That means before collision they will approach. While approaching relative velocity means change in velocity, that is u1 minus u2. Then after collision they will go far away from each other, their velocities are changes. After collision the relative velocity means change in velocity, right? And that is v2 minus v1. Then they are asking to show that the relative velocity of approach equal to relative velocity of separation. This is the relative velocity of approach. Okay, before collision they will approach, and this is the relative velocity of separation. That means after collision. Relative velocity means change in velocity. Change in velocity before collision, change in velocity after collision. Both are equal. We have to show that u1 minus u2 is equal to v2 minus v1. This is the first one. And second question is that they are asking to derive the find velocities of two objects. That means after one dimensional collision, they are asking the v1 formula and v2 formula. These are the two questions, right, that we are going to discuss. Okay, right. Have you understood the questions? Why you are not responding?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Now first we have to, this is the one dimensional elastic collision. In elastic collision, what happens? Momentum conserved and kinetic energy conserved. Is it right? Then according to law of conservation of momentum, what we write? Tell me. In elastic collision, both are conserved. Then let us write law of conservation of momentum it here. According to law of conservation of momentum, what we write? Conservation of momentum is obeyed. Is it right? Huh?
Yes, sir.
According to law of conservation of momentum, what we write? Momentum is constant. Is it right? The total momentum is constant. What is the momentum? Total momentum before collision? Huh? First body momentum is what? Mass into velocity.
U1
m1
mass
u1.
into
Second body momentum m2 u2. Is it right? This is the
U2.
total momentum before collision. Collision after the collision, what is the total momentum? First body momentum is m1 v1. Second body momentum is mass into velocity m2 v2. Okay, now what I am doing it here, I am taking this m2 u2 to right side and m1 v1 to left side. Then what you will get in the next step, that is m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Okay, we can common the m1 at here, that is u1 minus v1 is equal to m2 into, we write v2 minus u2, we write. Okay, right, this we can take as equation 1. This is according to law of conservation of momentum. Okay, And next, according to law of conservation of energy, we write according to law of conservation of kinetic energy. Law of conservation of kinetic energy. Do you know what is law of conservation of kinetic energy? Law of conservation of kinetic energy is the total kinetic energy before and after collision is remains constant. Can anyone tell what is the equation? What should be the equation? Total kinetic energy before collision you can add. Total kinetic energy after collision you can add. Both are equal because it is elastic collision. In elastic collision, total kinetic energy before collision equal to total kinetic energy after collision because kinetic energy remains constant. Can anyone tell what is the equation that we have to write based on law of conservation of kinetic energy? No one? Total kinetic first body kinetic energy
Sir, half m1 into u1 whole square.
u1 square. Second body kinetic energy,
Half m2 u2 whole square.
then total kinetic energy.
Half common हो जाएगा.
No, total means we have to add just. Right, then we write here. I will write. That is the first body kinetic energy is of m1 u1 square plus second body kinetic energy is of m2 u2 square. Kinetic energy means half mv square. Then after collision, what happens? After collision, velocities are v1, v2. Then the first body kinetic energy is of m1 v1 square. Second body kinetic energy is of m2 v2 square. Is it correct? This is equation 2. And now, oh sorry, we have to take another equation as equation 2. Now here we have to rub. What we have to do it here? We have to move this one to right side and this one to left side. Then what you will get? Yes, of m1 u1 square minus of m1 v1 square is equal to of 2 v2 square minus of m2 u2 square we will get. What I am doing it here? Okay, I am taking this half m2 square right side, half m1 v1 square left side. Okay, right? You can mute the button, right? Somebody is unmute. That's why disturbance is coming. And now we have to common half m1 at here. u1 square minus v1 square we will get. And here we can common the half m2 at here. v2 square minus u2 square we will get. This is equation 2. Now we have to divide these two equations. That I will do equation 2 by equation 1. Okay. Then if we will do that one, we will get like this of m1 into u1 square minus v1 square by m1 into u1 minus v1. On the right side, this one, right side of m2 v2 square minus u2 square by what we write? m2 into v2 minus u2 we write. This m2 gets cancelled and m1 gets cancelled, half gets cancelled, and this we write as a square minus b square formula we have in the mathematics, that is a minus b into a plus b we write. Okay, by we will get u1 minus v1. Is it correct? And here we write v2 square minus u2 square, that is v2 minus u2 into v2 plus u2. This is according to the formula, that is a minus b into a plus b is a square minus b square. V square minus u square is equal to, we write as v minus u into v plus u. Like that we can write. Then here u1 minus v1 u1 minus v1 and u1 minus v1, v2 minus u2, v2 minus u2 will be cancelled, and the next step we will get as u1 plus v1 is equal to v2 plus u2. Okay, right, this is you can consider as equation 3. Okay, that you remember this u1 plus v1 is equal to v2 plus u2 we got. Now I am going to rub this and you take the screenshot. Okay. Now I am going to rub it. Next continuation. Okay, you remember that equation. What is that equation? Have you remembered the equation 3? What is that? u1 plus v1 is equal
V1
to v2 plus u2, right?
U2.
Then we will take one term in this. That is this we will take to right side and this we will take to left side. Then we will get u1 minus u2 is equal to we will get as v2 minus v1, right? v2 minus v1. Is it okay? Right. This is equation we can take as it is the equation 4. This is equation 4. Okay, right. And what is this u1 minus u2? u1 minus u2 is what? Relative velocity, change in velocity. Relative velocity means change in velocity only. Relative velocity of approach, right? When they will approach, when they will approach, before collision they will approach, and then this is the v2 minus v1, v2 minus v1. Okay, then relative velocity of that one is what? v2 minus v1 is the change in velocity, that is relative velocity. Relative velocity of what? Tell me. Relative velocity of separation, right? This is after collision. The derivation is completed, and the second continuation we have to do, that is we have to derive the equation for the final velocity of first body and second body. Then we write from equation 3 we write one thing. Can you write the formula for v2 from equation 3? Right, what you will get? u1 plus v1. You see here, this is only equation 3. Again I wrote, right? From that v2 formula I want to write u1 plus v1 minus u2 we will get. This is equation 5, right? Now what we have to do here, equation 5 is substituted in equation 1, is substituted in equation 1. Do you know what is equation 1? Anyone? Right, what is that? m1 of u1 minus v1 is equal to m2 of v2 minus u2, m2 of v2 minus u2, but v2 we can substitute here, that is u1 plus v1 minus u2. This is totally v2 minus what is there in formula, m1 of u1 minus v1 equal to m2 of v2 minus u2. But v2 ka jagah mein, instead of v2 we are writing the v2 formula from equation 5, and then after that you have to multiply this, that is m1 u1 minus m1 v1 is equal to m2 u1 plus m2 v1 minus m2 u2 minus m2 u2 we have to write. And now we have to take few terms left side and few terms right side, and finally we have to calculate the v1 formula from this. If you substitute v2 in equation 1, then we will get v1 formula. If you substitute the v1 in the equation 1, then we will get the v2 formula. Here v2 we are substituting in equation 1, here we got in this equation we have the v1 only, then that we have v1 we have to calculate, and for that we will take this v1. Okay, we will write one more step at here, and what we write here, m1 u1 minus m1 v1 is equal to m2 u2 plus m2 v1. This we write here minus m2 u2 minus m2 u2 we will get is minus 2 m2 u2 we will get, and this minus m1 v1 taken to right side, and these terms we will take to left side. Then next equation we will get is m1 u1 is already there at here. What we are taking left side? This one we are taking left side, minus m2 u2 we will get. Something is wrong, right? m2, this is u1 na, this is u1,
U1 sir.
right? u1 it is. This is m2 u1, right? From this you see here m2 u1, and this we are taking to left side, then you will get minus m2 u1 on the right side here. Oh, some more thing we have to done, right? We have to take left side. This one also we have to take left side, and this minus will become plus, and it will becomes plus 2m2 u2 is equal to minus m1 we want to take on right side, that is m1 v1 plus, already m2 v1 is there on the right side. Then we will get this equation here, u1 is common, then we will get m1 minus m2 into u1 plus 2m2 u2 is equal to right side we have to common the v1, m1 plus m2 into v1. I want to find out the v1, final velocity of first body after the collision. Then we have to take m1 plus m2 to left side. Then when you will take that as left side, we will get m1 minus m2 into u1 plus 2m2 u2 by this will, when it will come to left side it will divide, that is m1 plus m2 is equal to, we got v1. I want the v1 formula, right? v1 is equal, we will get right side v1 left side we write, this one we will write right side, and this m1 plus m2 individually we will divide, that is m1 minus m2 by m1 plus m2. We write that is like this, m1 minus m2 by m1 plus m2 into u1. What I did it here, this individually you divide, plus, and here 2m2 by m1 plus m2 into, we write as u2, and this is the final velocity of the first body. You must remember this formula. This is equation 6. Okay, v1 what here, v1 what, tell me what is v1 at here. v1 is the final velocity, huh? Final velocity
Yes
of
sir.
first
First body.
body after collision, right? Okay, next we have to find out the final velocity of second body. Then today topic will be closest. More 5 minutes it will take. Then I am going to rub it. You take the screenshot. Now start again from equation 3. Do you know what is equation 3? Do you know what is that? u1 plus v1 is equal to v2 plus u2. From this you substitute the v1 formula. Okay, v1 is what? From equation 3, v1 is equal to what you will get? Huh? v2 plus u2. This is equation 3. Is it correct? v2 plus u2 minus u1. Okay. Now what we do here? Now v1 is substituted in equation 1. Okay, what is equation 1? m1 of u1 minus v1 minus v1 either. Then here we will get minus v1. v1 means what? v2 plus v2 plus u2 minus u1 is equal to m2 of v2 minus u2. What is equation 3? Equation 1 what? Equation 1 is this one. m1 of u1 minus v1 is equal to m2 of v2 minus u2. This is equation 1. And from equation 1, v1, instead of v1, we substitute the v1 formula, this one. m1 u1 minus minus, but in place of v1 formula we wrote from equation 3, and right side as this I wrote. Then let us simplify this, and before simplifying we multiply with minus, that is u1 minus v2 minus u2 plus u1 is equal to m2 of v2 minus u2. Now substitute, you multiply with that, m1 u1 minus m1 v2 minus m1 u2 plus m1 u1 is equal to m2 v2 minus m2 u2. Now we will take this, we have derived the v2 formula. Then for the purpose, we will take the v2 term one side and this term other side. And when you will do like that, then what you will get in the next step? And before that step, we have to do one more thing also. m1 u1, here we have m1 u1. When you will add both of them, we will get 2 m1 u1. Is it correct? m1 u1 m1 u1 2 m1 u1 minus m1 u2 minus m1 u2. Okay, these two terms we are adding, and this term is already there, here we wrote. And from the right side I am taking one more word, one more, that is m2 u2, right, plus m2 u2, minus will become plus when it will comes to left side. And then on the right side already m2 v2 is there. And now what I am doing it here, minus m1 v2 I am taking right side, then we will get this one, m1 v2. Then here we have to simplify something, that is 2 m1 u1 we write here. Here we can common the u2 at here. When you will common the u2, here we will get minus m1 plus m2 into u2 we will get, that is equal to, right side we can common the v2, then we will get m1 plus m2 into v2. Now I want v2 formula. Then for the purpose we will take that m1 plus m2 to left side. Then we will get 2 m1 u1 plus this, I will write m2 minus m1, m2 minus m1 into u2 is by what you will get. Okay, this is the left side. I am taking m1 plus m2 to left side. At m1 plus m2 we will get. On the right side what remains? v2 remains. Next I want to write the v2 formula. v2 left side you write, and divide this m1 plus m2 individually. Then we will get 2 m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. Have you understood this step? What I did it here? This m1 plus m2 individually I divided. 2 m1 u1 by m1 plus m2. m2 minus m1 by m1 plus m2 into u2. This is equation. Have you remembered the last equation number?
Sir,
Any mistake?
yes, sir. Either second last line, either side, left में. वहाँ सर प्लस M2U2 कैसे लिख दिए?
Where? Tell me.
Sir, second last either left में sir plus m2u2.
One second. Tell me. This one here. In the which step
Sir
you
ये
said? Once read the step.
sir 2m1u1 minus
Yes, yes,
m1u2
yes. This
plus
is step. Yes,
m2u2
yes.
yes
I
sir.
got it. I got it. And we have,
Yes
you
sir
see
plus
here. Right. Here m1 u1 is there, and here m1 u1 is
yes
there.
sir
Then that I added to m1 u1, and here minus m1
yes sir
u2 is there. I wrote here, and this one I
yes
am taking left side plus m2 u2. Is it okay? Is it okay, Vishal?
yes
Yes,
sir
sir.
Okay. Next, this is equation number. Last one. What equation number? 6 or 7 or what? Anyone?
7.
Last 7 means this is 8.
7.
This is equation
7, sir.
7. Right. Okay. Here what is V2? V2 is the final velocity of second body after one-dimensional elastic collision. Right? This is the today's topic we discussed at length. Right?